Okay, in this video I'm going to talk about factor label method of conversions and what that means. So I'm going to take a typical conversion problem or a simple conversion problem here. How many inches are in 10 kilometers? This is something that maybe you have been doing since elementary school or middle school, creating conversions, moving from one type of unit to another. So in this case, kilometers to inches. So you can take that in tiny steps and do a bunch of different problems. So for example, I run a lot of 5Ks and I know that that's 3.1 miles. So 10 kilometers, then I multiply that by a fraction of there's 3.1 miles in 5 kilometers, and I'm going to get an answer of that's 6.2 miles. Okay, and that's the first step, switching out of the metric system in this case. Okay, then I'm from Denver, so I happen to know that 1 mile is 5,280 feet because of the Mile High City. So I can take my 6.2 miles, multiply it by 5,280 feet for every mile. That gets your mile units to cancel, and that gives us 32,736 feet. Then we probably all know that 1 foot is 12 inches, so we can take our answer from here, multiply it by 12 inches per foot, and we get 392,832 inches as an answer. So you've been doing problems similar to this. Probably, I don't know if you've ever done this exact problem before, but you can do things like this multiple steps. It takes up a lot of space. Now I'm going to show you kind of what factor labeling looks like. Okay, again, this is the factor label method. And what it does is it organizes you. It gets you from your starting point to your ending point all in one calculation. You can tell that I'm using 5 kilometers is 3.1 miles. Okay, so my kilometers cancel out. 1 mile is 5,280 feet. My miles cancel out. 1 foot is 12 inches. My feet cancel out. Okay, and it works the same way as having a multiplication of a fraction here. Okay, you could even write it out, 3.1 miles over 5 kilometers with little multiplication signs in between. It's the same. I use a grid like this, okay? In this case, the line here was drawn for me, but you can draw your own line if you like that. And when I'm done, I grab my calculator and do it all at the same time. 10 times 3.1, divide by 5 because it's on the bottom, multiply by 5280, multiply by 12. We don't really need to worry about multiplying or dividing by 1 because that won't numerically affect the answer. Okay, and then you get your answer all at once. Now in this case, it's a whole number the whole way. If we had a problem in which we were ending up with decimals, every time we did a separate problem on the front, we would have been rounding our answer. Okay, this one was very exact. It was 6.2. There was nothing after. I didn't do any rounding. But if we had a problem in which there were big long decimals in our calculator, we'd be rounding at every step. And every time you round, you lose a little bit of accuracy in your answer. So in this case, when you put it all together and you punch it all into the calculator at the same time, you end up with an answer. And if you have to do any rounding, you only round once. You've got organization, you've got space-saving technique, you've got assurance that your units are all canceling, and this is how we're going to ask you to do all of your conversions in our chemistry classes. So when we get to chemical conversions and stoichiometry, you will be using this method, and that's what we're really trying to teach you here. Not how to do metric conversions, but how to use factor label method for conversions.